Okay, so in this problem, they want to know which sequence of transformations will take us from figure A to figure A prime. So here's figure A, here's figure A prime. So from A to A prime, and they do give us some choices here. It is a multiple choice question. As we look at the choices, we should notice that each choice starts with a translation, right? Translate the figure. And if you remember, a translation means a sliding of a shape. So here they're saying before you turn the shape, before you flip it, translate it, or slide it around on the plane. There are two types of translations happening here. In one case, they translate figure A negative 8 units to the left and 3 up. And in the other case, right, so those are both negative 8 to the left and 3 unit up. In the other case, they're saying 8 units to the left and then 3 up. Not negative 8, but 8 units to the left and 3 up. And we can quickly eliminate the first choice and third choice because what that does, right, if you translate, let's say, I don't know, point B, 8 units to the left and 3 up, right, that would bring us over here. So B is at 1, negative 6, translated 8 to the negative 8 to the left, which means really 8 to the right, right? Think about that for a second. This means 8 to the right because, right, it's a negative motion to the left, which means it's a positive motion to the right. It's just a really confusing way, I think, of saying a very simple idea that they're going 8 to the right. So if you see negative 8 to the left, that means to the right, and negative 3 units up would mean, as another example, 3 units down. Although I don't think anyone really would describe it in that way. That's what they're trying to get at. Now, if I have this point here, this is too far, right, from the origin. Let me explain what I mean. And this is why you can eliminate this point. This point is 9 over and 4 down. It's at 9, negative 4. Well, if I was to then rotate this some degree measure about the origin to get my image, right, this is further from the origin. That's the center of rotation. That means we're rotating our point around the origin. That's further from the origin than its corresponding point B prime over here. Or this is B double prime because I programmed in 2 translations for the image, but this is the corresponding point up here. This point is at what? Negative 3, right? Yes. Negative 3 and 7. So here, negative 3, 7, that point is closer to the origin. That can't happen. You can't have a point that rotates around the origin and have it move then closer to the origin. When you rotate a point around the origin, you just rotate it around a circular path. The distance from the point to the origin should never change. So you can't translate to a further place and then rotate and somehow end up back closer. That just won't work. So here, when we look at these other choices, right, what's going to happen in both cases is we're translating 8 to the left and 3 up. This brings our points to the same distance from the origin as their corresponding points. So let's say I take point F. F's at 5, negative 2. Well, if I go 8 left, where do I end up at? Well, if I'm at 5, negative 2, I go 8 to the left, I'm at negative 3, and then up 3 right here. Now that might be confusing at first because going 8 to the left brings me at negative 3 and then 3 up, positive 1, which is where this point is right here. But don't forget we're rotating it still. So the point F prime, or the point we're rotating to, is here. And that's 1, 3. And that's okay. Look at this point. 1, 3 is, right, if you think about the Pythagorean theorem, about how far that is, that's the square root of 10 from the origin. So is this right here. If you were to measure this line or calculating it from the origin, right, this radius and this one, they're equal. And when you draw a line of rotation from your point to the thing you're rotating around, in this case the origin, do the same thing at the corresponding point, and then measure the angle between, you'll see it's 90 degrees. Since these distances are equal, right, and this is if you look at the rotation, this is a clockwise rotation, right, in the direction of a clock. Here, this last one must be the answer. They tell us that they translate the figure 8 to the left and 3 units up, and then rotate the figure 90 degrees around the origin. So just to kind of reiterate what we said, in this problem, we go 8 to the right. and then 3 up. That kind of maps where the point goes in the translation. Then we find, does that rotate 90 degrees clockwise or counterclockwise to its corresponding point? If it does, you've got it. And the way, again, we knew was rotation is that the distance between a point and its corresponding point, the distance of those points to the origin is the same. And the angle between the lines that connect these points to the origin is 90 degrees. So it's almost like, this point's traveling on a circular path from one location to another. So this does indeed work. All right, now I know that was pretty tough. It was kind of hard for me to show it in this approach, but it's a good start, I think, to eliminate choices and to find answers by testing the graphs they give you. All right, thanks.